guys. Am I audible? Can you hear me? Can someone just type and then let me know? Can you hear me, guys? Yeah, cool. Thanks. So, hello everyone. Let's start off, today's session, which is career roadmap to data science. I'll just introduce myself. I'm Anirudh. I'm working as a business analyst at Ola. So I've completed a couple of internships. I've worked in Applicate AI as well as Triple IT Nagpur. In Applicate AI, I worked as a industrial. It was an industrial internship. I worked there as a data science intern for 6 months. In Triple IT Nagpur, I worked as a research intern, and both of them had completely different exposures. Uh, I've post graduated from data science, and I've graduated from mathematics, stats, and computer science background. So, without wasting any time, let's see what is the agenda for today. So, we're going to discuss about in next 1 hour. We're going to discuss about why do you want to choose data science and why do you have to choose data science. I'll just ask you, why data science, prerequisites for data science. Then we'll talk about applications of mathematics and statistics in data science. Then I'll try to introduce you to data science, basically a basic introduction. Then how can you excel in data science? Then data science life cycle. I'll try to demonstrate how exactly a data science project, life cycle of a data science project, basically. Then we'll talk about what are the different career opportunities in the market, and finally we'll end by Q&A. Let's start. So why do you want to choose data science? All right. I mean, I'll just ask you this question straightforward. So, I mean, why data science? Is it because of it has unbeaten salaries? The pay scale is very huge? Is it easy to grab job? Of course not. It's not very easy to grab job in any field, and data science falls into that category as well. It's not very easy to grab job. It's little effort is needed, but yeah, growing demand, it's a very huge growing demand of data science in almost every category, every field. And it's an evolving field, right? Data science is an evolving field, and it adds value to the business. So let's quickly have an activity. I'll just post you a link in the chat, and I want you all to give me the responses, and let's see how it goes. Please do this activity, guys. I will have a quick 1 minute, and I want you to fill this, and we'll see what exactly, why do you exactly want to do data science. I just want to understand this. So let's have this activity, and we'll see what is the response from the people, how exactly it goes. Take a minute, and let's do this. Guys, I've posted a Google form. So I just want, I mean, for the ones who are not active so far, so I've just posted a Google form in the chat, and all you have to do is you have to go there, select an option based on based on what you choose is right, and just submit it. That's it. Can you confirm me, have you filled the form? Just to see. I hope all of you have done it. All right, so let's see with the results now. I'll just try to share my screen for a moment. So the one, if you cannot see my screen, I'll just read out for you the distribution. So we've got some 8 responses. We are still getting some responses. That's great. So 12.5% of the people say it's an unbeaten salary. They're choosing data science because it's unbeaten salary. You're getting high paying salaries. Other 2.5% people say, just because my fun friend or cousin has suggested me to choose data science, that's the reason I'm choosing it. It's good. And 25% of the people say it's because evolving field, that's the reason I'm going to choose data science. And 50% of the people say it's growing demand, extreme demand in the market. That's good. Got it. Thanks. So, yeah, thanks for that activity. I don't know whether you have could screen my screen. Yeah. So you have understood why do you want to choose data science, but I would also, this is a question you should not answer me. I mean, you should ask yourself, does data science suit you? Or maybe any career that you choose, uh, does it suit you? Are you going to survive it? Can you survive all the difficult circumstances? Can you survive all the challenges in life that in the process of going through any field, say data science, say software engineering, say anything, you're going to ask your question, can you survive all the odds? And what if you fail? Do you have a backup? Say you have in the process of going through a data science course, say all of a sudden you felt it's very hard, I cannot do it, the mathematics is too tough, or the statistics is too high to me, I cannot understand. So can do you have a backup? You should have a backup. Otherwise, it's too difficult to handle such a situation. And lastly, do you have all the prerequisites? Let's see then. So So why data science? I mean, this has been an old image that I've got from the internet, and I'll try to. This basically summarizes everything pretty much of AI or data science. So it said that it has very huge demand, and AI deployments bring 50% of the revenue growth. They bring a lot of money to the companies. Yes, salary is 20% higher than the ones who have clicked on salary. Yes, 20% higher than the software engineer. And then fun, yes, if you can really teach some cool stuff in AI. Yes, things that matter, obviously, I mean, data scientists are the ones who are the modern heroes, right? So they create some amazing stuff, innovative stuff. I'm not saying others don't do it, everyone does, but I'm talking about data science. So uh, yeah, that's why. And yeah, they make work really easier. And actually, if you play a game versus human being versus AI, then obviously AI is going to win because it's trained. And it can make some good artists as well. So deep learning can make you an artist too. All right. And you can predict dangerous diseases, you can diagnose with diabetics, you can create some smart boards, you can detect the fraudulent transactions, you can do almost everything in AI. Anything which is a problem statement that you can, I think, most of them you can solve through AI or data science. So this is something I was talking about. Can you survive odds? You think data science is easy. I mean, maybe it depends on individual to individual, but in reality, I must say that in one or the other phase, you will have to pass through the hardships. You will have to face the difficulties. You will have to face the challenges, and then only you will see the taste the success of any field, or be it in our case it's data science. So prerequisites, yeah, this is something really important. So data science is a combination of mathematics, statistics, and computer science. By the way, I forgot to answer my why did I choose data science? I chose data science because when I was doing my graduation, when I was in my second year of the graduation, I got a chance, and I just got a chance of attending a workshop, machine learning workshop in BITS, Hyderabad. And by then I didn't knew what exactly was data science, and I just wanted to know, out of curiosity, I just wanted to see. I thought this is some new technology, and in the second year of my graduation, I had no idea. Uh, I was just learning by then. So I just thought, why not to attend this workshop? It's just in a 10 days workshop. Although I didn't, I knew that I'm not going to learn complete machine learning in 10 days. That's something which is impossible. But I just thought, if what exactly is this technology? Out of curiosity, I just thought I'm going to have some kind of basic idea, but let's see what exactly is this. So by then I had no clue of what exactly was data science or machine learning. So we were five friends who were from mathematics, arts, and computer science background. In initial, first few days, he was just talking about, the guest lecturer was talking about, say coding, or we need to install that package, that package. Then we have to install some softwares, all of that stuff. Then when exactly we were talking about, the guest lecturer was talking about the regression analysis, or say chi-square test, all of these, because this all of these have studied in second year or maybe in the first year itself. So I kind of had an idea of what exactly he was talking about. But among the 500 or something audience, very few who had already learned stats and math kind of were understanding, but majority of them, to sort of say, were not at all following the lecture because it's pure statistics, right? So, and mathematics basically. So majority of them were not understanding. So then I thought, this is what is for me. I mean, this is what has striken me into my mind, and that's wherein I thought, machine learning and data science is not very far to me. It's actually very near, and this is something which I can, probably pursue easier than any of the other fields. When I was thinking about what to do next, this is what struck me in my mind, and that's the reason I've chosen data science. So even for you all, you have to ask yourself, why are you choosing data science? I mean, what is that one thing that's striking in your mind because of which you are choosing data science? And you have to stick to it. You have to stick on it, and then, not lose it, not to, leave till you achieve it, till you achieve certain stage. So yeah, let's get back. So prerequisites for data science. So data science is a combination of mathematics, statistics, and computer science. And mathematics and statistics are the, backbone of, basically, data science. Is I mean, mathematics and statistics is the backbone of data science, to sort of say. So yeah, what exactly do we have to learn in mathematics? What exactly do you have to learn in statistics or computer science? So in mathematics, you have to be good at linear algebra. Linear algebra is the core for, major machine learning or deep learning algorithms. Then calculus, both integral and differential calculus. You have to be very good at both of these. You have to be good at probability theory. You have to be good at probability distributions. We have discrete and continuous. I will be, detailing all of these in a moment. Statistical analysis, and you have to be good at statistical inference. You have to be good at programming. So as you can see, algorithms of programming and mathematics. This is what, this is what is put together a machine learning, right? So, and then data structures and algorithms, then database management. So all of this, if you are aware of, or maybe if you think, yeah, all of this, then you're good to go and study data science. Otherwise, you will have to prepare all of this. You have to be, aware of all of this. You have to kind of have basic understanding of each of these concepts which you are not really aware of. Say you're not aware of statistics, then I must say that you have to, concentrate on statistics. Say you're not aware of mathematics, say linear algebra, you're not, say you're weak in mathematics, try to, concentrate on, say, at least the basic stuff, so that you can just pass through the algorithms and understand what exactly is happening. So understanding of all of this is really mandatory. Otherwise, you cannot really, understand the algorithms which talk about, which really, deal with pure mathematics. So we'll see what are the different applications of statistics and mathematics in data science. I have listed very few here, but there I must tell you that, as I've said before, mathematics and statistics are really a backbone of, these two are, backbone of data science. So I've listed very few here, but there are numerous applications of data science. And I must say, mathematics and statistics are the, it's built up, both of these are built together to make data science. All right. So, loss functions, univariate and bivariate analysis, regularization, covariance matrix, support vector machine, sampling, pre-processing, hypothesis testing, Bayesian statistics. In dimensionality reduction, we have principal component analysis, singular value decomposition. In natural language processing, we have word embedding, latent semantic analysis. In computer vision, we have image representation, convolution, and image processing. All of these. I mean, there are many actually, but the ones which I've listed are, purely involved with mathematics and statistics. So what exactly is data science? Or, as soon as someone, is asking you what exactly is data science, then, you kind of say, data science is pure math. It's a combination of mathematics, statistics, and computer science. But yeah, it also means that you're using some kind of algorithms. You're trying to use methods, processes, and using all of this to extract knowledge. And extracting knowledge from noisy, unstructured, and structured data. And through this, you'll try to generate some actionable insights, and which may be, of some use to the business teams, or maybe some use to the problem statement, business problem. And what exactly is AI then? AI is something which, it tries to mimic the human brain. It tries to, describe machines that mimic and display human and cognitive skills that are associated with human mind, such as learning and problem solving. So as a human being, we try to learn as well as we have a capability of the problem solving in the same way AI tries to mimic the human itself, and it has the capability of learning and the problem solving. So, what exactly comes first? Is it AI? Is it machine learning? Is it deep learning? So, yes, AI is basically a superset, and in which we have data science, and data science, then we have machine learning. In machine learning, we have deep learning. So, to sort of say, machine learning was initially made. I mean, list of machine learning algorithms that we have are the basic ones, and deep learning algorithms are to sort of say, they try to find solutions to the hard problems or the complex problems which machine learning algorithms cannot do it. So that's the reason we have, or maybe in a easier way, they can easily solve the deep learning problem. So the problems can be easily solved by deep learning. So that's the reason machine learning, is a sort of superset, and deep learning is a subset of machine learning. So what exactly can we do? I mean, we know what, assume that what is machine learning and deep learning. Then what next? Assume. So we can solve CV, we can solve computer vision problems basically, and we can solve natural language processing. So what exactly do we have in natural language processing? Say we have, you're supposed to do something like, sentiment analysis. Say you're supposed to categorize, a tweet. Say you're doing a Twitter analysis, you're trying to see for each tweet whether it's a positive, negative, or a neutral tweet. Or maybe maybe I say you're a good boy, so is it a positive statement, or is it a negative statement, is it a neutral statement? So all of these analysis, or maybe speech recognition, you're trying to, input a speech and trying to see which who has, really spoken it, or whether it's a positive or negative or neutral. Or maybe it's, is it a Donald Trump, or is it, President of India, who is exactly speaking? That's called speech recognition. And in CV, we have, say you insert a photograph of yourself, or maybe, just an example of your phone itself. As soon as, face recognition happens, or maybe if you're an employee, then, face recognition, as soon as you enter your office, maybe then you will see, your name being displayed on it. It's all because of the CV computer vision. It's trying to, every day it's getting trained, and every day it's recording. Every day the model is getting trained on your name, and every day it's saying that, oh, maybe Anirudh is looking like this, or say Ravi is looking like this, or Madhavi is looking like this. So every day, the model is getting trained, and it's trying to recognize it and save it, maybe feed it in its mind, and then trying to predict it on everyday basis. So computer vision, NLP, all of these again come, I mean, not come actually, they are, all of these are solved using computer vision, deep learning and stuff. So how do you excel in data science? I mean, so what is the things that you're supposed to know, or what are the things you're supposed to concentrate on in each of these different aspects that I'm going to cover in next few minutes? What is that you're supposed to know? So you're supposed to know linear algebra completely, as I've said before. You're supposed to know vector calculus. You're supposed to know matrix calculus. Supposed to know optimization. What are different optimization techniques? What is regression, what is dimensionality reduction, and what is, classification, all of these. In probability, yeah, probability and statistics are, again, very key concepts in data science. In discrete, you're supposed to be aware of binomial distribution, Bernoulli distribution, geometric, hypergeometric, Poisson distribution, all of these. And in continuous, you have uniform distribution, exponential distribution, you have gamma distribution, gamma first kind, gamma second kind, beta first kind, beta second kind. Then you have normal distribution, you have multivariate normal distribution. And you need to be aware of probability. There is theoretical probability, there is classical probability. You have to be aware of all of this. And you have to be aware of 1D array, sorry, 1 dimensional random variable, and 2 dimensional random variable. How do you solve it? How do you solve a particular use case? the function of a random variable, what exactly is joint probability density function, what exactly is marginal sorry what exactly is joint probability distribution, what is distribution function, what exactly is marginal distribution, and what exactly is, I mean, all of this, probability constitutes of all of this, and which you are supposed to be, something which you're supposed to be aware of, to sort of say, to go ahead with, with the go ahead of machine learning at least, because all of this, we'll see at some point of the other time, you know, see, you're trying to see a data set, you have to understand what kind of distribution the data set possesses, so that accordingly you will have to take the next steps. So in statistics, you have to be you need to have some kind of understanding of random samples, and you need to have an understanding of sampling distribution. There are two, there is sampling with replacement, there is something as sampling without replacement. Then you be aware of parameter estimations, what are the different ways you can estimate the parameters. There are numerous ways, like maximum likelihood estimation, there's numerous ways. Then hypothesis testing, then ANOVA, then we have stochastic process, and we have simple linear regression, correlation, multiple linear regression. All of this, maybe I'm not trying to read everything for you, because some of them are really important, some of them are not really very important, but overall, all of these are something which you have to be aware of. Programming, what exactly you're supposed to know in programming, you have to be good with Python basics. Maybe if you're using Python or R, you can be good at any of one of those. I mean, majority, I mean, and, Python is now universal tool for the data science, to sort of say. So everyone uses Python these days. So if you're good at Python, that's really good. So in Python, you have to be good at, say, basics, say list, all the data types, mutable, immutable data types, then NumPy, pandas, what are the basics for importing the data set and stuff. Then not Matplotlib and Seaborn, all of these are used for visualizations. Then database, you can be good at SQL. SQL is, it's good enough, I think. Then in others, you have, I mean, in R, I mean, the same thing in R. So you can be good at R basics, vectors, lists, all the data types. Then DPLYR, all of these. Then in data structures, data structures actually play a really important role. Say you're supposed to design an algorithm tomorrow by yourselves, then you have to be good at data structures and algorithms. Web scraping, we use web scraping, just to sort of say you have to extract the data from some source. Say you want to scrap Wikipedia data, or maybe you want to scrap some kind of tweets. You want to see what are the different Instagram posts that people usually do. So all of these, maybe I'm trying to generalize it, and to sort of say where exactly you can use web scraping. Basically, web scraping you can use to extract the information, extract the data, and maybe what next is a different problem statement, and that's the reason we use web scraping for. In machine learning, you'll be probably you need to understand how exactly a model works. You need to have an understanding, maybe mathematical understanding, theoretical understanding, to sort of say of how exactly model works, what are the basic data exploration techniques that what are the different ML models that are there, model validation, how do you validate a model, whether this model is performing good or whether one model is performing better than others. Model validation, underfitting and overfitting, how do you I mean, all of these technical terms you may not be aware of, but I'm just trying to give you a gist of what exactly are the data science, what exactly is there in data science. And this is very to sort of say, if you have an understanding of to this, maybe you can start off with a project. So that's the reason I'm trying to give you a gist of it. So you need to be good at, say, ensemble methods, that which is like random forest and decision trees, all of these. Then you have to be good XGBoost, all of these. Then we have how do you handle missing values, how do you handle categorical data, how do you handle imbalanced data, how do you handle the different problem statements come in, how do you handle skewed data, how do you handle irregular distributed data, all of these. Then how do you handle, um, I think this is enough. Pipelines. How do you build a pipeline, ML pipeline? How do you validate, cross validation? Uh, how do you handle data leakage? Yeah, this is super important. Then in deep learning, you have ANN, you have artificial neural network, you have convolutional neural network, we have a recurrent neural network, and the implementation of these can be done by Keras, PyTorch, or TensorFlow, and deep learning neural network. Then we have optimization algorithms, stochastic gradient descent or batch gradient descent. We have numerous optimization algorithms. Then how do you handle overfitting and underfitting in deep learning? In deep learning it's different, and in machine learning it's different. The way of handling the overfitting and unfitting problems, and there are different techniques to that, such as dropout, batch normalization, then mini batch normalization. Sorry, there are different ways to handle deep learning. Overfitting and underfitting in deep learning as well. And then we have some kind of different kinds of problem statements associated to it. Say you want to do it binary classification, you want to do it maybe as I said, you want to do sentiment analysis, maybe text classification, or you might say object detection, or image recognition, all of this. So, what exactly is there in future engineering, or what exactly you cover in future engineering? So you have to identify the baseline model first. A baseline model is something which gives you a score, which is the first one to be implemented. I'll try to showcase you what exactly is the baseline model in the coming slides. What is the future generation? What is future selection? How do you encode categorical variables? How do you encode ordinal variables? Then in natural language you have to be okay with text classification or word vectors. Data visualization, you can be good at Excel, or you can be good at any of the tools that are available for data visualization online. Deployment, and deployment is basically the last step after entire model building. So, and other points, you have to be good at communication skills, and that's super important. You have to be good with domain knowledge, which is business knowledge. Then further which you have to keep practicing, because this is not the end, this is just the start. This is wherein you have to start working even more and more. So this is to give you a gist of how exactly people think, after knowing machine learning, and or maybe after doing a couple of projects in the machine learning, they just think that data science, they, you can use high quality. In theory, it's like let's use one of the high quality data sets provided by our institution. But in real world, the data sets are terrible. I'm telling you, data is really very terrible. And what you can make is making it less terrible, or making it less of it's kind of very terrible, guys. I mean, I don't know how to describe it, but it's very vulnerable to sort of say, and you have to make it less vulnerable, something similar to that. And in theory, you can implement as many neural networks, as many deep learning frameworks. You can do this, that, maybe for a simpler problem, even for a say a classification or regression problem, you can do deep learning. But in reality, because of the size of the data sets, because of the constraints that are set, you cannot start with a deep learning or something like that. You will start off with something very basics, and basic models to for the initial solutions, and based on which, if you have got some time, based on the business requirements, you'll try to expand, or you'll basically improvise it based on the needs. So what exactly is the data science life cycle? Assuming that you're doing a business, sorry, you're doing a project, then how do you go through the data science project? Like, you'll first of all understand the business, like what exactly is this for. You need to have a thorough understanding of the business, business understanding, in the sense, what is the sole purpose of doing this data science, or what is the sole purpose of doing this project. How exactly are the results being used? All of this, you need to have a complete understanding of the business. Otherwise, you're lost here, you cannot proceed ahead. And in data mining, say you don't have the data itself, then you're supposed to gather the data, or you're supposed to scrape the data and get the data. Data cleaning, once you've got the data, then you try to see what is the inconsistency or maybe redundancy, try to eliminate all of these and make the data clean. In exploration, you try to have some kind of statistical inference. Say, say in the next week, the COVID cases may rise again. This is my hypothesis. Now, what percentage of this hypothesis is true is what the statistical inference says. And then future engineering, the idea here is that you try to sort of eliminate the redundant futures, you try to make the futures more meaningful, you try to pick only those futures which are super important. Say you're doing a project wherein you're trying to predict the employee salary, then you don't need, say, employers say employees past, what has he done in the past, say the marks in his code in his 10th grade, all of these you don't need, right? I mean, say I give you 10th class marks and I give you something which is super important, which is his designation or maybe his experience. So among these three variables, maybe employers marks in 10th class, how do you really need it? You don't need it, right? So future engineering, you can eliminate those features which are of no use and make the future metrics best in a best possible way. Predictive modeling, once you're done with all of this, then your task is to make a machine learning model. Now machine learning, any model, and upon which you're trying to do a performance metrics. Now once you're done with the machine learning model, you try to see how exactly is it performing, and then data visualizations. Once you're done with all of this, the idea is that you kind of going to show the predictions to the stakeholders, trying to say that this is how we're going to predict the model, these are the predictions that we have got, and finally that's how maybe the next steps is deploying, or based on the requirement of the business problem. So assuming that you've got a fair idea in data science, then what are you supposed to do? So you can pick any open source data set, understand the business problem thoroughly. Now if it's a regression problem, then start off with a regression analysis. If it's a classification problems, then start off with some basic project using all the classification analysis. Now as a step, what you're supposed to do is, I'm assuming that you're using only supervised. Maybe if you're using unsupervised, then that's a different topic altogether. So this is only for those who are beginners to data science, or maybe those who are some part, yeah, aware of what exactly you're supposed to do. They're aware of data science in some or the other way. Others who are not aware, that's fine. What you can do is you can have an understanding of this is the flow that you can follow, and then you can proceed ahead. So in regression analysis, there are different regression techniques. Say linear regression, then we have knn, then we have support vector regressor. So you can use any of these regression analysis, maybe all of them, trying to see, trying to understand how exactly all of these work. It's not like you're using one model and then you're done. That's not how it works. You have to use as many algorithms as possible, see the behavior of all of these models on different on the same data set. Then base classification, use all the classification algorithms, try to identify or try to see the behavior of it and see how exactly they go about it. Now before that, before you implement all those models, the idea is that you have to spend a lot of time in the future engineering. You have to spend a lot of time in the pre-processing. Now, pre-processing, see, as I've said, the data in theory is really good, but data in reality is super horrible. So that's the reason you're supposed to spend as much amount of time as possible in future engineering. Yeah. Once you've got fair idea about the data set, right, then you can start building the basic model. The idea of this basic model is you can pick any model you can be considered as a basic model, and start seeing how exactly is the score. So you say you're getting 50% accuracy, or 50% is the score that you have got. It's fine. So the idea is that when you when you choose, then that's the baseline score, above which you have to, that's like a threshold. So above which you have to perform, above which the models that you choose upon next, or the process that you choose upon next, should be better than 0.5, or maybe 50%, better than 50%. And now start building multiple models. So you can use cross validation, you can use any of the methods and pick the three best models. My idea is three best models. You can pick five best models and then tune the parameters for all of these models that you picked are the best ones. Then upon which you try to see, use the best model in predicting the test set. In the sense, once you've got three best models, you're supposed to predict it on the test set and then see how exactly are they performing. And you have to pick one among the three, and you use them ahead. So you can use the best model and then evaluate it on the test set with different metrics. So many people who have known, they would just consider one metric. We have different metrics for any problem. So use all of them and see where exactly the model is lagging. And the idea is that you have to try to improve that metric which the model is trying to fail. All right, and start post processing. Now in post processing, the funda is that you have to kind of have all the visualizations, see how exactly the model is performing on the different use cases or test cases, and see, if the model is not performing at a certain worst test case, then you have to maybe improvise the model. In the sense, you have to sort of say tune the hyperparameters, or maybe retrain the three models that you have picked the best ones, see which one is performing again, and then finally conclude it. Now, once you're done with all of this, then you can finalize the model that you think is the best, and the model that you felt it's giving good predictions, it's giving good score. You can use that and deploy it for the future predictions. Now, what are the different career opportunities in the market? So data, we have some, I've picked three. There are numerous career opportunities. Like, there is something known as data science associate, there is something known as, yeah, there is a data analyst, there is a business analyst. There's like something like, if you go to the finance side of it, there is something as credit risk analyst, something like that. So the opportunities in the market for data science alone are numerous. So, and you really don't have to worry until unless you have good fundamental skills, and good fundamentals rather. So the definition of data scientist is the one who makes data-driven approaches. He tries to make data-driven decisions. He's looking into the future and taking innovative and initiative solutions. Whereas data analyst is someone who is using current tools and algorithms to solve data-related problems, rather than something the data scientist might not do. And business analyst is someone who's handling the data and indicating systems while being able to communicate well at many levels. But the idea, the only difference between data analyst and business analyst is business analyst actually communicates to the stakeholders regarding his reports or based on his insights that he gathers. Whereas data analyst, all of these are, you know it depends from organization to organization. Say, the place I'm working in, I actually try to do something in data science. Though I'm a business analyst, as a business analyst, you may not have to do much in data science, but here in my organization, I try to do something in data science. So it depends on organization to organization. It doesn't mean that you're a data analyst, you cannot use data science. You can definitely use data science. You can use for different use cases. You can um, you know improvise it, seek with your manager or anyone else in your team, say this could be a best fit in this use case or this problem statement. And skills required, yes, statistics, programming in R, Python, and mathematics are super important for a data scientist. For data analysts, programming, statistics, and visualizations. Business analyst, SQL, sorry, R, Excel, SQL, and Python. So, and visualization, of course. So visualization comes into the picture when, you know uh, I mean there are numerous applications of visualizations. So, like, one common thing in this is all of these roles use visualization. So you can use Power BI, you can use Tableau to see how exactly is the data behavior of the data. You have can understand through various um, visualization tools. That's the reason we use visualization tools for the business decisions, and yeah, for the business decisions mainly. So yeah, let's have Q&A, and let's see how exactly what exactly you guys have. Do I need to be good at programming to succeed as a data scientist? Programming is important, but really good is I will tell you what exactly. So the idea is that you need to be good at mathematics and statistics. Assume that if you're good at mathematics and statistics, then then I think computer science is it's okay. I mean, all the algorithms that are built are on the paper first, and then they are implemented through code. So if you can figure out how exactly these algorithms are made and how exactly is the process, then programming is like a cup of coffee to you. So that's how you can say programming can learn eventually if you don't know, but programming is just used for implementation purpose. Yes, you need to have these skills in programming. Any more questions, guys? Any more questions? Let's jump onto that screen. Any kind of questions that you guys have? You can ask anything related to data science, or maybe the questions that your mind